Professor Thompson again. I'm going to go back and do some closed interval method problems from 4.1. So I'm going to try to find some slightly weird ones here. So the first one is 4d6, which is f of t equals t plus cotangent of 1/2 t. And I want to find the absolute minimum and maximum on the interval pi over 4 to 7 pi over 4. Okay, so part of this is that I have to get the values at the endpoints. And you're just going to have to use your calculator for this because f of pi over 4, that's going to be pi over 4 plus cotangent of pi over 8, which is a gross number that I don't know off the top of my head. So let's find that number real quick. So for that number, I got 3.1996. And now let's check 7 pi over 4. So I don't need the exact number yet. I mean the exact form. I can just leave like this, but I just want to see, using decimals, which things are the highest and lowest. So here I got 7.912. So that's a lot higher than the first one. So now what I need to do is I need to take the derivative, find the critical values, and check the value of the function right here, not the derivative, the original function, at the critical values. So let's take the derivative on the next slide. So the derivative here is going to be 1 minus, the minus coming from the fact that cotangent of 1/2 t is going to give me minus cosecant squared, 1/2 t, and then for the chain rule, it's going to be times 1/2. So if I set that equal to 0, so you can just make this 0, because that's when I'm going to check for critical values. I also care about when sine is 0, because that would make cosecant squared undefined. So that happens, I guess, at 0 and pi. But that would mean, because of the 1/2, I'd have to have 2 pi. So those are outside of my window. So I don't care about when cosecant's undefined because it's actually defined in this tiny region pi over 4 to 7 pi over 4 because of the 1/2 t. So I need to check when this is 0. So I have cosecant squared 1/2 t times 1/2 equals 1. So it's really cosecant squared 1/2 t equals 2. So I'm going to write this as 1 over sine squared 1/2 t equals 2. Right now you can invert both sides in this case, so this is basically just cross multiplication shorthand. So this is 1/2. Now I need to take the square root. So let's go to the next slide. So I'll have sine of 1/2 t equals plus or minus the square root of 2 over 2. That's what the square root of 1/2 is. And we know that that happens at sine, if I'm using plus or minus, that happens, I guess it's like from 0 to 2 pi first. That happens at, so 1/2 t would be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And of course beyond that. And so, because we're going to multiply by 2, we might want to go a little farther in both directions. So let's back up again. Because we're going to check, after we multiply by 2, we're going to check what's in our region. So before that would be minus pi over 4. And after that would be 9 pi over 4, 11 pi over 4. Let's go to 13 pi over 4. So basically, this happens every pi because of the plus or minus, but now when I multiply by 2, I'm going to look at what's in my region here. So the fact I'm multiplying by 2 just means I'm going to make all these denominators 2's instead. So minus pi over 2, pi over 2, 3 pi over 2, 5 pi over 2, and I can stop here because I'm only going from 7 to 7 pi over 4, which is almost 2 pi, right? So this is past 2 pi, so I don't use those. And this is clearly outside of my region. Pi over 2, though, and 3 pi over 2 are in my region because they're 2 pi over 4 and 6 pi over 4. Now, I wrote a lot more than necessary up here, but the reason why is because, for example, if this had been 2t, when you divide, you'd bring stuff outside your region into your region. So I just wanted to double check, but I see that I just get these two answers inside my initial domain from pi over 4 to 7 pi over 4. So that means I've got critical values here of pi over 2 and 3 pi over 2. And so I don't care about the derivative anymore. All I know is that those are possibly interesting numbers, and so I'm going to go to the original function and plug them in. So this is t plus cotangent of 1/2 t. And so if I plug in pi over 2, I get pi over 2 plus cotangent of pi over 4. Well, tangent of pi over 4 is 1. So is cotangent. So this is pi over 2 plus 1. But I need to check what that value is. So what I got here was 2.5708 if I round. And then at 3 pi over 2, well, that would be 3 pi over 4 for tangent. So if you just think about tangent first, at 3 pi over 4, I believe it's minus 1 there. And so cotangent would also be minus 1. And so overall here we would get 3.7124. So now what I need to do is look at all 4 numbers I found. So at the beginning I found 2 other numbers, but I believe that 2.5708, so pi over 2 plus 1, that's the absolute minimum because that's the lowest of the 4 numbers. But then if you go back to the right edge, this was the highest of the 4 numbers here. So there's your absolute minimums and maximums.